Okay, I think let's maybe we can restart again. It's 9:35. Maybe we can wait for one more minute and then we will start our second session. So. Nishan, do you want to check just the transition of the slides very quickly that you are?
Yeah, sure. Thanks, Isham.
Yeah,
okay. Yeah, transition. Okay, great.
Sometimes it's taking time to do the
transition. Okay, then I will go a little slow.
No, it's good. It's good. I think when you did it now, it was good. So.
Okay, let us start, right, Sham?
It's just me. Yeah, it's a moment. Let me just introduce you very quickly. So
okay, sure.
let's have the second session for Sensing River workshop. This session will be on the big data and cloud computing application and remote sensing. And our speaker is Nishan Biswas. Nishan is a research assistant at University of Washington in Seattle. And he's doing his PhD research on mainstreaming the application of multi-satellite observation in water resources monitoring and management. And Nishan is actually very passionate about using his programming and web development skills to build and design a complex hydrologic operational systems. And as you probably you saw in the Dr. Faisal's presentation, he recently launched this tool called the RAT, or Reservoir Assessment Tool, and it's monitoring reservoir operation at a global scale. So Nishan will introduce us today to this field of big data and cloud computing, and how can we apply that in remote sensing and water resources with more focus probably on the Google Earth engine. So please join me in welcoming Nishan Biswas. And yeah, Nishan, you can go ahead and start.
Thanks, Nishan, for introducing me. Again, so my presentation will be more of like what is the concept of big data and cloud computing, which is like roaming out us in recent times, and also like how we can apply this recent concept in information technology in the field of satellite-based remote sensing. So yeah, let us go through it. So my session will be more of interactive. I think there will be some interactive options. So you can stop me if you have any pressing questions, or you can wait till the end. Yeah. So in my presentation, first I will talk about the concept of big data in remote sensing, and then I will be talking about like how we can process remote sensing data using the traditional methods, and what are the challenges that has been faced in traditional methods, and what is the role of cloud computing here. And finally, I will show one really interesting cloud computing platform, which we call Google Earth Engine. And then I will show a few examples from Google Earth Engine. Yeah. So let us start with remote sensing data. So I want to thank Dr. Faisal Hussain for introducing you the satellite remote sensing and how everything works in there. So now this is one single satellite image that I took. And in here, you can see that there are like individual pixels. So this is the individual pixels. I think the screen can be is visible, right, Hisham?
Yes,
the transition is working. Yeah, okay. Yeah, so these are the individual pixels in that satellite image, and then so now we have like individual pixels which might be 3 meter, 30 meter, or 60 meter, or even like 1 meter, 2 meter in satellite visible images. And also we have number of rows and columns in one single satellite image. Again, in some satellites, they have the capability to measure the strength of returned energy from object in spectral bands. So there is another dimension which we call spectral band dimension. For example, Landsat have 11 bands like blue band, ultra blue band, and other band. Moody's has 35 bands like that. And all of these satellites are revolving around Earth. That means like they're taking photo at a fixed interval. Say, for example, for Landsat it is 16 days, for Sentinel it is 10 days. So these there are 4 dimensions in total. One is like pixel dimension, how is the size of the individual pixels. Then there is number of pixels, rows and columns, and there is like spectral bands, and again there is temporal direction. So, and one good thing from here is that when there is like increase in one dimension the data, that means increase in the size of the data. So now the question is that how big is the remote sensing data? Let's see. So here I took one example from Landsat satellite. If you can see that one single scene from Landsat satellite is around 2 gigabyte. So how big is 2 gigabyte? You can imagine that the one HD quality movie will be around 2 gigabyte, not ultra HD quality. So that's one single satellite scene. And we have around 5 million scenes of Landsat imagery since beginning of Landsat era. And that means total of 3,000 terabyte of raw data. This is just raw data. We have also level 1, level 2, level 3, level 4, which means like processed data. So now you can imagine that how big is the data size of a single satellite mission. Now we have like, if I just imagine the imagery satellites, for example, Landsat, Moody's, and Sentinel. This is one comparison of the like individual data size of these satellites. The axis is in petabyte, which means around which means 1024 terabyte of data. So this from here you can imagine the how big is the size of this remote sensing data. So from one administrative organization from in USA, which is called National Oceanographic and Atmospheric Administration, they have shown that they need around 160 petabyte of data in 2030 to accommodate all the satellite remote sensing and model data sets. All of these data sets are only Earth observation data sets. And these are particular organizations, which is National Oceanographic and Atmospheric Administration. They just work on Earth observation and different techniques and models related to it. So that's 160 petabyte of data size. So the question is that, do you think that this is big data concept? So actually this big data concept is very recent in the Internet of Things era. So still the like definition varies from like study to study. But the main thing is that there are 3 main V of this big data, which is volume. So the volume of these data sets need to be very large in terms of petabytes. We already saw that the remote sensing data sets that are available is in petabytes. And there should be a large variety of data sets. Yeah, in remote sensing data, we also saw that there are large variety of data sets available. For example, we have vector data. That means like different attributes of different cities data or geolocation data. We have raster data, that means like Earth observation data with a fixed grid size. We also have different pixel size of data sets. Finally, the third V is velocity. That means like streaming of data sets in computational framework, or also like we can think of it in such a way that every day how much new data we are getting from satellite observations. So we can say that this remote sensing data qualifies for all 3 V of big data concept. So obviously remote sensing data is a big data platform, and processing of this remote sensing data is also a like tedious job. There are some challenges with the traditional methods that we have been focusing. So for example, this is a satellite data, and there is like connected ground stations to communicate with that satellite. Now, if you want to process the satellite imagery data to make it useful for your region or your interest, what you need in your end. So obviously we need high bandwidth of internet, because you already saw that one single satellite scene is around 2 GB. So now you can imagine that if you want to process some satellite data, how much internet speed you need. Also, you need high processing power with a big storage capacity to process all of these satellite data sets. And also, if you want to process these data sets, you need some proprietary softwares, for example, ArcGIS, which is not free at all. You need to pay for that. So one example is shown in here. It is for High Aswan Dam, and High Aswan Dam, and the chart here, it is water exchange area of High Aswan Reservoir. Now, I think Hisham will explain it in the later session tomorrow. But for now, this is like the reservoir behind the High Aswan Dam. The surface exchange area of water of that dam is processed here. So for now, what I want to illustrate from this chart is that if you consider one single point in this chart that considered around 5 to 10 satellite scenes of Landsat, that means it's around 10 to 20 gigabyte of data to just generate one single point in this chart. Now you can imagine how much data has been processed and how much storage you need to create a time series analysis, something like this, using your own computational framework or whatever you have at your end. The concept of cloud computing is that we do not need any of this. We do not need high internet connectivity. We do not need large storage. We do not need a high processing power machines or orchestrations. We do not need proprietary software. What we need, we just need a normal desktop that you are using for your day-to-day task and a browser. What it will do, it will go to cloud computing framework where everything is stored, like every data sets and like all the remote sensing data sets and their attributes are stored in that cloud computing storage facility. You just need to go to that particular web browser or whatever it is, or an interface, and where you can process all the information without having those high internet connectivity or storage or whatever it is. And finally, you can get your useful information from there. So this is the concept of cloud computing, that you do not need to like buy any of this hardware or software or internet connectivity, and still you can get useful information from satellites using cloud computing. Now the available platforms in cloud computing, there are a lot of publicly available cloud computing framework. For example, Microsoft Azure, Google Cloud Platform, Amazon Web Service, IBM Cloud. But yeah, there is one question that all of these services are completely free. No, it's not free actually. You have to pay to use their services, and this cost for using a single machine is shown in the chart below. So here, like the price of this, the price of these services also varies from continent to continent. You can see from this chart that like in USA, the price is different. In Asia, its price is different. And the chart also shows that like different types of cloud computing framework, for example, AWS, Google Cloud Platform, or Microsoft Azure, their price is also different. But one good thing is available for us, which is Google Earth Engine. Google Earth Engine actually is connected to the Google Cloud Platform, and it's completely free. There's the one good thing which is available for the Earth observation workers or specialists, whatever it is. You can use this service, Google Earth Engine, to process the satellite imagery and everything in there without without any cost. So Now, is all the data sets are available in Google Earth Engine? Yeah, we have like around 200 public data sets in Google Earth Engine available. For example, Landsat, Sentinel, Moody's, and you can also get elevation data, terrain data, land cover data, weather and climate data is in there available for you. And every day we are getting more than 4,000 new images in there for your purpose. And they have more than 5 petabytes of data from Earth observation and remote sensing platforms. One more good thing about Google Earth Engine is that you can upload your own raster or vector datasets. You can use your own raster datasets. You can upload it via Google Map Engine, and also you can use your vector datasets in the Google Earth Engine platforms. I will explain about this later. So the question is that what can we do in Google Earth Engine? One example is shown in here. So this is like an image that you can get from Google Earth Engine, where you can just specify everything as your required resolution and everything, like bounding box, like which area you want to focus and how you want to visualize the image. Then you can apply an algorithm to that image. So this algorithm means like anything which is useful for your purpose. For example, if you want to know the water body of your area, you can use normalized difference water index or enhanced vegetation index for vegetation purpose or land cover purpose. So there are lots of library functions available in Google Earth Engine that you can call, or you can also write your own script to process that image, to convert that image into a useful information for your purpose. Now that you have the algorithm that you developed to process that single image, you can just filter the whole collection of images. You can filter the collection of images according to the time or space or metadata. For example, if you need to process useful information by considering the Landsat images from 2010 to 2020, you can do that. Or if you want to just focus on single Landsat scenes, you can filter that one as well. Now you have filtered collection, but you can apply the algorithm that you developed over that single image to the whole collection of images. So now you processed all collection of images using the developed algorithm, and you have a number of images according to your requirement. Finally, you can reduce that collection. You can reduce all the collection of images into a single image, or you can also convert them into a different number of images in order to get aggregate statistics, for example, maximum, minimum, or whatever it is, or time series analysis that I showed in the earlier slides. So you can do that using this Google Earth Engine. Now, the question is how this framework is working, or what is the workflow of Google Earth Engine. So, for example, here I showed one single image, which is the original image. Now, what Google Earth Engine usually do, like it divides the original image into 256 subunits. You can see from this figure that the original image is divided into a number of images. Now, these images will be distributed to a number of CPUs or to a number of machines, because in Google Earth or in any cloud computing platform, you have a number of machines available. Now you can see that the sub-images from that original image is assigned to individual machines to process parallelly to convert them into the useful information that you are trying to get from Google Earth Engine. So finally, all the results from the single sub-images is converted again to the original image size to produce the finished image. From here, we can see that if we just consider the processing power of Google Earth Engine or cloud computing platform, you can see that it is 256, it should be 256 times faster than your own machine or your own workstation or your own desktop machine. So now I'm going to the Google Earth Engine link to show you like what it looks like. So Here, this is the website for Google Earth Engine. You can see this is just earthengine.google.com. So here, first you can see all the available data sets in there. If you click on the data sets, if you want to view all the data sets, click on the view all data sets, and you will be able to see a number of data sets which are available in Google Earth Engine. You can see some of them are global coverage, some of them are regional coverage data sets. Also, you can browse by tags. For example, 16-day resolution data sets or 3-hourly data sets, whatever it is. You can also browse by Landsat collections, for example, Landsat 8, Landsat 7, Landsat 5. All of these data sets are available in there. Also, let's see some time-lapse videos that will help you to understand that, like how fast is the processing power of Google Earth Engine. For example, let's see the irrigation of Saudi Arabia. This is the irrigation facility which is getting improved in Saudi Arabia. Here in the bottom, you can see different years, and you can see the evolution of irrigation facilities in Saudi Arabia. With all of these images has been processed in Google Earth Engine to generate this animation. So yeah, this is the homepage that we have seen. Now, the question is that how we can use this Google Earth Engine, like what are the ways to use this Google Earth Engine. One, the first way and most used way is the JavaScript API. API means application programming interface. So API is usually used to like give you access through a system by using an interface. So you can use JavaScript API, or you can use Python API, or there is another API which is being used by like Google developers in Google Cloud Platform that is also available. But most frequently we use JavaScript and Python API. JavaScript API to write codes and interactively see the data sets and useful information. And Python is used to used in a console application where you can import Google Earth Engine libraries and all other things, and then you can process images in console way, not the like interactive browser way. So there are two different ways to get access to the Google Earth Engine. One is the Explorer. So it is shown in the left side. It is actually more of like lightweight geospatial data viewer. So here you can view the data sets, you can filter the data sets, and there are some other algorithms available which you can use to process those data sets. One good thing about this Explorer part of Google Earth Engine is that you do not need to write any of the codes. You just do the click, 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 and all other things will be done by the Google Earth Engine backend. The problem with this Explorer is that as you cannot write codes, obviously it will be less flexible compared to the code window or other options. For that reason, you cannot do complex analysis in this Explorer one. And there is another window is available, which is code window, where you can write your own code and process the geospatial data sets or remote sensing data sets. You just can do anything you want to produce that information that you need from that satellite imagery. But the problem with this or limitation with this code window is that you have to have the JavaScript coding experience, very, very basic level, not very advanced level. Let us see now the Explorer window. So this is the Explorer window of Google Earth Engine. So you can see this one. The one thing about this Google Earth Engine that it is already signed in using my Google account. But if you did not register for it, you have to register first to get access to this window. So now let us add some data sets to see. Say here there's a Landsat data or Moody's data. You can search here any of the data sets. If we search for precipitation, you can see there's precipitation. And here's the precipitation that you can see, which is covered the tropical region or even air region. So this is the way, and also you can use different computational for apply mask, extract mask, and other options is available in there, which is not focus of this workshop because we will be using more of like code window rather than this explorer window. So now let's go to the code window. This is the code window, how it will look like. So here you have in the left panel, you can see that there is the scripts and datasets docs available. In the middle panel, there is the code editor where you can write code. In the right panel, this is the task manager where you can see your results. And the lower panel, this is the map. Actually, it is better to go to there, see. Let's go there. So this is my Google account that already registered. That's why I just clicked on my Google account to get access to this window. So here, this is the main window of this Google Earth Engine. In the left panel, you can see that there are different scripts that has been written by me, and also like there are other scripts also available which you can use for your own purpose. There's docs available where different algorithms has been explained, which you can use. For example, this is like canopy edge detector, or this is FMAS to filter out clouds. All of these things are available in here in the docs. And in the assets tab, you can upload your own vector data where you want to say you have your region of interest, or you have the Egypt polygon to process the satellite imagery data. You can also use that one in there. And here in the top panel, you can search for any of the data sets, say for Landsat or whatever it is, say precipitation. You can see that interactively the filtered search results are coming in there. And this is the panel window where you can write your own code. You can generate link to code, any of the codes that you have been written. And this is the link that you can share with anyone. And they can also see your codes. And you can also save the codes that you have been written. So, and you can run your script. And finally, this is the right panel where you can you can see that whatever your result is. And in the console window, you can just see, in the console window, actually, you can see the results. And in the inspector, you can click on the windows to see like what is the point lat loss, latitude, longitude, and every information regarding that. In the task, if you export anything from Google Earth Engine to, let's see. So in the task, if you provided a task in Google Earth Engine, that can also be there. So yeah, that's actually the code window of Google Earth Engine. We will talk more in the upcoming sessions about this code in the code window of Google Earth Engine. So don't worry about that. I just wanted to introduce you to the main window. So yeah, so this is actually the code window that I just showed you. Now, there are several options in code window that I was showing. Like you have the docs available, where different functions has been written. You can use those. The assets, so you can just import your own shape files or own vector data to process the satellite imagery. And finally, you have the help button. So if you go there, on the right corner of this window, there's user guide is available, and actually developers discussion group, and also like questions and answers of different problems. You can get information from there. So now let's see one very simple demo of remote sensing data processing in Google Earth. So again, I'm searching for a data set. Say, let's search for global surface water data set. This is the global surface water data set. When you search, and if you click on the search results, you will see information about those layers. So here, this is a global surface water mapping layers, which means like they have the water surface map of the whole world, mainly for inland water bodies from 1984 to 2019. You can see here the dataset availability date. Say this is March 1984 to January 2019. And you can, if you click on here, you will see the information about the dataset provided. So this dataset contains map and location, temporal distribution of surface water datasets. So if you see the bands, there are different bands available in these datasets. You can see that there is occurrence and like seasonality, recurrence, maximum extent. You can see all this information. What is that citation of these datasets? You can also see from here. So now let's import these datasets into our map. So if you click on import, then it will be imported in the top panel of your code writing window. So now let's add that map in Google Earth. So how we can add that map? You can just write map dot. So actually there are several bands in the dataset. Let's first filter that band. Say I'm just providing a variable name there, and then say image dot select. So this will select the occurrence map of the datasets. Again, what is the occurrence map and how I know that? So here in the bands, you can see that this is the occurrence. So that means like the frequency with which water has present. So it should, the value is from 0 to 100. And the resolution of these datasets is 30 meters. So this is the occurrence. And then now I will add that occurrence map in our Google map. So this is map.add layer layer, and then let's run. Okay, sorry about that. That's not. Yeah, so here you can see that inland water bodies has been visualized using that image. So this is actually the image that has been that is being shown over the base map. So here you can use different visualization parameters. For example, you can use parallels. You can select different colors. Say this is my low occurrence of water bodies. This is high occurrence of water bodies. So yeah, and now you can see the different, like you can see inland water bodies or water mapping, occurrence of water bodies in different areas of the world. Yeah, that's like very simple script that I wanted to show you. Now you can save your script. So if you click on save, then it will save, and you need to provide a name of that script. Okay, I think my internet is a little bit buffering. Yeah. So yeah, now using this save button, you can save your script, and also you can get the link to your script and copy, and then you can provide this script to anyone who wants to get access to this script. Now let us say another one complex application that has been developed as part of one of my projects. So this is actually focused on northeastern region of Bangladesh. So here, what this region is actually flash flood prone region. That means like floods come very like first from the upstream area. And here what we did in Google Earth Engine, like we had some modeling frameworks, and we validated those models using the satellite data. Those satellite data has been processed from Google Earth Engine. So as you can see here, the satellite that has been used to develop this one is Sentinel-1. And what this script is doing, like it is generating a chart for this water body of this region. So here the blue color means like water bodies, and the white color means like the non-water bodies, say land or whatever it is. And also it is generating another image So this is actually the water surface area dynamics of that region. Now, if you click on any of the points on this chart, you can see the corresponding images of that, like flood images of that region. So for this one is actually for, here you can see that date, July 2019, when the like high flood is occurring in there. And this is the like low flood time. This is in March 2019. Yeah, this is this script also developed using this Google Earth Engine. So what I did, like here, after writing the script, you can also publish apps from there. So here you can use new app and you can provide relevant information, and then you can publish your own app from the Google Earth window. Yeah, that's it from my side. Now I'll be taking questions, and yeah.
Thanks very much, Nishan. Yeah, that's a great presentation. I learned from this presentation a lot. I mean, I've been working with you in the same group on Google Earth Engine, and with some stuff that's the first time to know about this from the presentation. So thanks very much. So there is one question from Dr. Ashraf Mustafa. He's asking if can I export those files as shapefile or raster files?
Yeah, actually, you can export your findings from this Google Earth Engine, but it will be saved in your Google Drive. So you need to connect your Google Drive, or you actually have to be same account holder of Google Drive and Google Earth Engine. So from Google Earth Engine, then you can export your results in your Google Drive, and you can get access to those results in your Google Drive.
And the extension will be shape files and or raster files?
Yeah, you can export anything, shape files or raster or whatever it is, statistics, summary statistics, or whatever you want.
Okay, thank you.
Yeah, you're welcome.
Thanks very much, Dr. Ashraf. Any other questions? I mean, we have like 20 minutes if you want to ask questions. So yeah, go ahead, Muhammad. You are raising your hand. You can ask a question, Muhammad. Unmute yourself and go ahead and ask a question. Yeah.
So there is another question from Ahmed Iladai that,
okay,
yeah.
This is just Nishan, I think, Muhammad. Okay, Muhammad, I think we are not able to hear you, so probably you can type your question, or you can maybe send the question to Nishan as well, because we are still, I think, not able to hear you. Maybe you still have some issues with the mic or something.
Also,
so we can take the next. Yeah, Nishan, you can take the next question from Dr.
Yeah.
Ahmed.
Let me just write my email address. If you have any particular question, you can also email me. But yeah, but one question from Ahmed that he has been trying to use Google Global Surface Water dataset, but for my case, I tried to use these datasets and I never got like corrupted images. So if you can specify the region that you are working, or like if there is any month, a specific month that you are working, then we can get down to that error sources. But for now, I never saw any corrupted images in Global Surface Water data. Yeah.
Okay, next question. Okay, Muhammad. Muhammad, you have a question, or Mahmoud? Sorry, Mahmoud, you have a question? Muhammad Alamin, yeah, go ahead.
Okay, thank you. I have a question concerning the data volumes, the chart that you showed earlier. I didn't get it in accordance to the Landsat data. If you could just show the chart of the data volumes of the different satellites in the very beginning.
Mm-hmm. Let's see. Are you talking about this one?
Okay, I cannot see it.
Maybe
Okay.
you need to share the screen, Nishan.
Yeah. Yeah. Are you talking about this chart?
It didn't. No. In the first beginning, the chart that showed the data volumes for different satellites.
Okay. Oh, so this chart. Yeah. So here actually we try to mention that how big is the satellite data set. So here there are several satellites has been shown. For example, Landsat, MODIS, and Sentinel. these are three different imagery satellites, and how big
Yes,
is
yes,
your...
yeah, this one. Yeah, concerning the Landsat, why the data is consistent like this? I didn't understand it.
Actually, it's not very consistent, but the increase in size is not big like the Sentinel and other satellites. So Landsat is also like Landsat is the spatial resolution of Landsat is very coarse compared to the other satellites, for example, Sentinel-1 or Sentinel-2 or Sentinel-3, because the spatial resolution of Landsat is 30 meter, whereas Sentinel-1 is 10 meter, Sentinel-2 and 3B is also fine resolution. That's why their data size is so big compared to the Landsat. And Landsat size is increasing, but is not increasing like the other satellites, because the spatial resolution of Landsat is very consistent from the beginning. It is 30 meter for the visible and infrared bands.
And what about the accuracy of the data?
Yeah, that as Dr. Faisal Hassan already mentioned, that the data sets, when you are trying to get any of the satellite data sets, you first need to think about the accuracy for your particular region and where you are working and which temporal span that you will be working. So it depends. If you focus on any of the region and any of the temporal span, then the accuracy, first you have to like analyze the accuracy if you have any reference data, and then you can like apply those data. But for now, like there is the accuracy of these Landsat varies from time to time and also region to region.
Oh, okay. Okay, thank you.
Yeah. I think there is one more question.
Yeah, there's a couple of more questions, Nishan. I think you want to read it, or you want me to read it, or?
Yeah, like there is one question from Mohammed Ahmed, that what do you mean by the 3B that you showed us in early talk? What do you mean by parallel computing? Okay, let's see. So 3B actually is used to define the big data. I think you can see my screen, right?
Yeah, just your slides now we can. Yeah, this is the slides of the 3D.
Yeah, so when you are saying that a particular data set is treated to be as a big data, that means there should be 3B. That means volume, variety, and velocity. Volume means like your data set should be as big as terms of petabytes or zettabyte, and also like there should be a large variety in the data sets. For example, in our remote sensing platform, we saw that vector data, raster data, and different pixel size of raster data. That's why we are saying that there is large variety of data sets available in remote sensing platforms. Also, the velocity of data sets need to be high. That means like streaming of data sets when you will be analyzing those. Or also like if you think about like how much data sets are coming or in like recent days or every day, how much new data we are getting, that's the velocity of data. So that's 3V, volume, variety, and velocity. Yeah. So I think that answered your question, right, Mohammed Ahmed?
His mic is not working, Nishan. So
Oh, okay. Yeah. So I'm assuming that.
Yeah, he's asking like the parallel computing as well, and there is two more questions.
Oh, okay. Yeah, there is another segment of Mohammed Ahmed's question that was this parallel computing. So when we are saying that we have a multiple number of stars, let's see. I think this slide will be a good one to explain the parallel computing. So here, in the cloud computing, so you can look at this slide that in cloud computing, they have number of machines or whatever you can say, or virtual computer, central processing unit. Like it's just like a number of workstation or desktop that you have been using or laptop you have been using. So when a specific job is distributed among all of these machines available in that cloud computing, this is saying parallel computing.
Thanks, Nishan. Yeah, parallel computing. Yeah, I think as you said, Nishan, like because we usually use like one computer for processing. So the idea I think here on the parallel computing, as Nishan mentioned, is we are using these multiple computers on the server. So I think we have one more question, Nishan. can we import the observed data to Google Earth Engine to be used in the scripts? This is from Mahmoud from Kyoto University in Japan. So you can answer. Nishan.
I think, yeah, observed data means like if you have any shape vector data, you can obviously import them using the assets in Google Earth Engine. And also you import your raster data using Google Maps engine. That's a different framework from Google Earth Engine. So you have to register in Google Maps engine. And in there, you can upload your own raster data. And again, you can use that in Google Earth Engine.
Yeah. I think we have a question. Yeah, finally, we have one from Alexandria University. So, yeah, we have a question. It's from Hadir. She is asking if we can export the raw data for a time series.
Yeah, actually, for raw data for a time series means I am assuming that you are trying to say that can you export raster data which will be processed to generate the time series? Yeah, you can export your raster data. So if you export your raster data, it will be connected to your Google Drive account and it will be exported to Google Drive. Finally, you can use your raw data like the raster data from your Google Drive, and then you can process your own timesheets from there.
Yeah, thanks, Nishan. Let's see if so. Any other questions? I think we will be actually in the practical session. We will be trying to be working more with the Google Earth Engine, and like we will have like 2 practical sessions. So today we will just kind of like very basic how to import the data and visualize some of the data like precipitation or something, and if you want to focus on your specific region. So we'll try to do that during the practical session. And I think I just want to also stress here that the idea of the Google Earth Engine is to do everything on the server. So make sure that when you think about Google Earth Engine that we are not downloading the data. So everything you will be doing it on the server. So try not to download the data, because I mean you can download the data to your Google Drive, but the idea is, I mean you can export the data to the Google Drive, but the idea is always to do everything on the server and try to minimize what you are going to export to the Google Drive. For example, just maybe the output, the final output, if you want to maybe creating maps or something, because I think, I mean, maybe Nishan, you can correct me, but Google Earth Engine maybe is not that good in producing like nice maps, or maybe, so you might need just maybe an output to process it in your own codes, like using MATLAB or using Python to produce like a very nice map for publications or something. So
yeah, that's true.
Yeah. And yeah, do you have like any other questions? And let me ask also about the registration, because I think I sent you like the instructions for the registration. So I think I received a message now from I think from Mahmoud or I think from Muhammad Ahmad. He said like he cannot register in the Google Earth Engine. So I'll try to help Muhammad during the practical session. But can you just like kind of like a general question, like if someone you can just like there is that button yes or no. So can you just tell me if you are able to register to the Google Earth Engine or not? Just I mean, yeah, just want to make sure how many are not able to register to Google Earth Engine. And by the way, I know we have some guests that they just get the emails yesterday. Maybe they don't know about the Google Earth Engine and understand it if they don't register for Google Earth Engine. But so we have now 4. I think 4. They said yes, they are able to register to Google Earth Engine. I think you can. I don't know if you see the yes, and yeah. Now we have 5. That's good. 7. Yeah, Dr. Ashraf, yes. Okay, Ilham is saying no. So we will try to help you, Ilham, in the practical session. Muhammad as well, he said no, so we'll try to help him. I think, yeah, I think Ilham maybe didn't get the email for, I don't know if you get the email to how to register or not, but we will help you during the practical session for sure. And yeah, so I think 9 said yes, and yeah, maybe we have like 2 or 3 said no. But I think that would be great. I think if we will work in the practical session in groups. Like I'll explain that this at the beginning of the practical session, and be like 5 groups as I mentioned in my email last week. And I mean, if we have like 2 probably that they already registered for the Google Earth Engine, I think this will be enough so we can do the practical the exercise. I think the exercise I shared yesterday, it's very simple, and you have also all the steps, so you can very easily follow the steps and you can do the exercise. Even I totally understand that the time is very short for the practical session, so if you'll not be able to finish the exercise during the practical session, that's totally fine. I mean, you can work on it later today or even after the workshop, and I'll be happy to answer all your questions later. Just something a reminder before we have a break. We will have the break at 10:30. So before the break, just a couple of things. I'll be sharing the PowerPoint from Dr. Faisal and from Nishan as well. It's okay, Nishan, to share the presentation on the Google Drive?
Yeah, sure. I will upload it in Google Drive. Yeah.
Okay, great. So yeah, just want to make sure I take permission from the speaker.
No, it's
so,
okay.
Okay, so yeah, so we'll have the presentation. You know there is a folder. Can actually share with you my. Yeah, I'll share with you the screen for the Google Drive folder very quickly, so you have an idea about the folder. So yeah, you can see I think you can see now the screen. So here's the folder, there's a presentation. So I will be adding here the slides and the recordings. And then the practical session, you will find, here are some tutorials. This is not the tutorials from us. It's just, you will find it online and you can find more and more, but I just added here some of them. And I will try to add more for the Google Earth Engine. And here is the teams. I think we organize the teams into like 5 teams, and probably know that every team will have a name. So like I just selected a kind of the very large, like kind of large river basins all over the world. So and it will make it easy for us to kind of know each group, and everyone can easily identify his group. So we have the Amazon, Columbia, and Mekong, and I'll share this maybe before we start the practical session, the Nile and the Rhine River. And this is the teams, and then also in the practical session, you will have the exercise. So I uploaded this exercise and I sent it to you as well yesterday in the email. So the exercise, you can go through the steps. I mean, you will find everything. Yeah, is like is explained. So if you go through the steps, you'll find it easy, and we'll be around during the practical session. So if you have any questions and if you have any problems, so we can help you. And then finally, here's the papers. So for each topic, you will find some papers if you want to read more and explore more about this topic. For example, the satellite remote sensing, you have 2 papers. Mostly there will be a kind of review paper, so not too much getting into, I mean, details of research or something, but it will be reviewing a kind of like the status quo of the remote sensing. And then as well for the GE, I uploaded 3 papers yesterday. This one actually is the Golic paper in remote sensing of environment. This actually is a guy from the Google who started this Google Earth Engine. So he wrote this paper in 2017 on Google Earth Engine. So it's very good if you want to read it. And there is another one in IEEE. It's published this year in 2020. It's a review paper on the applications of Google Earth Engine in water resources. So if you want to read more about that, that's be helpful. And we will add more and more papers here on this folder. Yeah, this, I think the miscellaneous, as I said, it has nothing. It's just the Zoom guide I shared before, and also the agenda if you want to check it again, and you can visit the website as well. I think that's everything. It's good that we are in time, so we can, I mean, anyone has any question before we go to a break session for 15-minute break, and then we come back maybe maybe we'll convene back at 10:45, so we'll have the last session, which will be a practical session. And I'll try to create the breakout rooms now. And just for those who are like not, they didn't apply for the workshop, but they are a guest, or I have them in the guest list. If you're interested in attending the practical session, just send me a private message here, and I will add you to one of the groups, so you can work also with others in the Google Earth Engine the hands-on. You can also work on the hands-on and practical session, and I will share the materials with everyone. So even the guests, I will share with them the materials later. So I think I have the email of the guests as well. So I will send you the materials and the Google Drive folder so you can access the materials. I think if there is no any question, I think it's maybe it's time. It's 10:30 now, so it's time to go to a break. Yeah, you can take a break, stretch your legs, and have your coffee, and let's meet back at 10:45. Thanks very much, and see you soon at 10:45.